Okay, the rest of this section is just continuation of a bunch of examples. This is example number 5. It says solve the equation log of x plus 3 plus log of x minus 5 equals 2. Well, just like the last problem, I want to put the two logs together, right? So I'm going to put the two logs together. So you're going to use the, it's actually called the product rule, right? The sum of the logs equals the log of the product. So that's what I did, the right to left on rule number 3 of logarithms, property number 3. So we get that. I didn't do anything to the right, I just rewrote the left as a single logarithm. I compressed the left side. Comes out like that. Remember, when you have a product like this after log, it means that that whole thing is inside. It looks like I actually planned to clarify that by putting another bracket in. Let me write that in. It doesn't hurt to put extra parentheses just to make clear what's going on. So let me see, I need blue. Okay, so what I really wanted was, let's just move this. I wanted this little bracket here, just to make it clear that those are inside. Okay, here we go. Okay, now I want to get rid of the log. That's log base 10 because it doesn't say anything. It doesn't say what the base is, so it's got to be 10. So I make the left side of the equation and the right side of the equation the exponent base 10. This is why I wanted a single thing on the left instead of the sum. It just makes it a little easier to have a single thing. Because the sum, you couldn't do 10 to the first one and plus 10 to the second one. It doesn't make any sense. It has to be 10 to the left-hand side equals 10 to the right-hand side of this equation here. Okay, so now these two are going to cancel. And I'll get this quadratic, right? And I just multiplied the quadratic out on the left. X plus 3 times x minus 5 gives me x squared minus 2x minus 15. Check that. Right? And 10 squared, of course, is just 100. So now I'm going to subtract the 100 over. And make sure you do that right. Okay? And then I'm hoping I can factor it. If I can't, I have to use the quadratic formula. And I couldn't factor it, so I use the quadratic formula. Okay? And you should know that by now. And then I'm just simplifying that. Gosh, I'm doing every single step. Okay, and you should know how to do that from previous sections too. If you don't, then you have to go back and review it. Okay, so 1 plus or minus 2 square root of 29. Those are my two answers. Now, you need to check your answers in these logarithm equations. I forgot to mention that before. You always check your answers. And the reason is because you might end up, well, with logarithm equations, sometimes you end up with fake answers or spurious answers, just like with square root equations. So you have to plug it in. There's two things that can go wrong. One, you could end up taking a logarithm of a negative number or 0, which doesn't work. So you'd have to eliminate that solution, or it just doesn't work. You get real numbers, but the left side doesn't equal the right side. So I want to compute the left side. And I can do that pretty easily because it's log base 10, so I can just throw it in my calculator, right? So I did, and I'm not going to write it all out. What I would do is just take 1 minus 2 square root of 29, put it in memory, put it in the memory X on your calculator, and then you just type out the equation that's up above, log of x plus 3 plus log of x minus 5, enter, and it'll automatically plug the memory in. Then you go back and you change the memory to the one with the plus and do the same thing, okay? And see if you get 2. And the minus one doesn't work and the plus one does. The minus one will actually give you an error because it's going to give you a log of a negative. Actually, both the logs are negative. Both the arguments of the logs are negative if you use the first one there, the one with the minus. So that's really messed up. So if you plug that in, you just see numerical error. Num error. It means the thing you plugged in is not in the domain. So it's just got the one answer, and you'll miss this if you don't check the answers, which you're supposed to be doing anyway, whenever possible, right? Okay, now I'm doing one, and I just decided to do one with ln. So the first thing is you want to get that coefficient out of the way. This coefficient right here, you want to get that out of the way. So remember, it goes inside and becomes the power of the inside, part of the argument. So the argument here will be x plus 3 squared, right? It didn't do anything to the right at all. Now I want to get rid of this log. Well, it turns out I can get rid of both these at the same time, which is really nice. I don't have to put this over here and combine it. I could. It still works. But I don't have to, because if I do e to this power and e to this power, it gets rid of both ln's at the same time. 2 for the price of 1. Right? So that's composing both sides with an exponential function base e, which is a lot of words, but very simple to do. Right? Those cancel, and I get that. Multiply out the left side, combine like terms, because the 12x will go to the left side, become minus 12x, and then try to factor it. If you can't, use a quadratic formula. Right? That should factor. That's x minus 3, the quantity squared. That's a perfect square. So I only get one answer here, which is 3, and I still have to check it, though, to make sure it works. Yeah, it's going to work. I can go through the properties and see that. But just put it in your calculator. Find the left side, right? Just evaluate it in the calculator. I would write it down first. Always write things down first before you evaluate them. You make fewer mistakes that way. Yeah, just approximate it. Should have just written down the approximation. I simplified it slightly for some stupid... Oh, just to make it easier to plug in. That's the only reason I did that. The right side, right? 36. So ln of 36, it checks out. If they came out different, I would go back and try them both again, just from scratch, because I probably made a mistake on my calculator. Okay, so on to, I think the next one is the last one.